Hey everybody! So today we are going to be working on division problems or fractions involving roots. And some advice I've already given you about multiplication that is also true about division is that you can always divide a regular number by another regular number. So like regular 50 divided by regular 5 is regular 10. And you can always divide a root number by another root number. So like root 12 divided by root 3 makes root 4. And so then you just see if you can simplify at the end. In this case, I have 10 times the square root of 4, or 10 times 2. It turns out that this random division problem is actually equal to exactly 20. And for a problem like this, again, I can always divide a regular number by another regular number. 16 divided by 2 is 8. I can always divide a root number by another root number. So root 15 divided by root 5 is root 3. And since I don't know the square root of 3, this one's actually stuck. This one does not simplify the way that one did. Okay, so what I wanted us to focus on is that sometimes you don't have the option to divide right away. So this is a great example of it. I have 8 divided by the square root of 2, and I can't divide right away because one number is a regular number and one number is a root number. You can't like combine them naturally. So it turns out there's a really easy trick you can do if you need to do a division problem like this. And what that trick is that you just multiply the top and the bottom by the denominator. So it seems kind of weird, but what we're going to do is we're going to say, okay, I can't do 8 divided by root 2, so I'm just going to multiply both the top and the bottom by root 2, by the denominator. Okay, so what happens there? On the top, those two can't combine, so that becomes 8 times the square root of 2. And on the bottom, I have the square root of 2 times the square root of 2, which makes the square root of 4 also known as 2. So this problem has become 8 root 2 over 2. And so now I actually can do the problem because I know that regular 8 divided by 2 is 4, and the root 2 just comes along for the ride. So the final answer to this one is 4 times the square root of 2. If you look at this next problem right here, it's very similar. It's just you can actually do something at the beginning. At the beginning of this problem, I say, okay, well, I know that regular 40 divided by regular 2 is 20. Like, I know that I can do the top divided by the bottom in terms of the regular numbers. 40 divided by 2 is 20. But that root is stuck in the bottom because I didn't have a root on the top to divide it by. Okay, so what do we do when we have a root stuck in the denominator? Whenever you have a root stuck in the denominator, multiply by the denominator. So in this case, the denominator is root 10. I'm going to multiply by root 10 over root 10. I'm going to get 20 times the square root of 10 on top. And on the bottom, I have root 10 times root 10, which makes root 100, also known as 10. So I have 20 root 10 divided by 10. Regular 20 can be divided by regular 10. I'm going to get 2 times the square root of 10. Okay, so let's do some more practice with that. Some people call what we are doing right now, when you divide by roots, rationalizing the denominator. So that's what some people call what we're doing right now. Rationalizing the denominator. And what that means is we are making the denominator a rational number. We're making the denominator into something nice so that hopefully we can actually divide. And so when it comes to rationalizing denominator, there are basically like 2 major strategies, and you've already seen one of them. So one of the major strategies for rationalizing the denominator is that if you have a root stuck by itself in the denominator, you multiply by the denominator. Multiply by the denominator. This works whenever a root is stuck all by itself in the denominator. So if we do one more like that, let's say, for instance, that we had like 12 divided by the square root of 3. I can say that because I have a root stuck in the denominator by itself, I'm going to multiply both the top and the bottom by the denominator. Root 3 over root 3. And of course this is allowed because whenever you multiply by something over itself, you're just multiplying by 1. You're not actually changing the answer to the problem. You're just writing it another way that might be more useful. So the top here becomes 12 times the square root of 3. the bottom is going to become root 3 times root 3, which is root 9, also known as 3. So this became 12 times the square root of 3 divided by 3. And because I now have a regular number over a regular number, I can actually do 12 divided by 3 is 4. This answer is 4 times the square root of 3. Okay, so unfortunately, multiplying by the denominator doesn't work for every single problem. It doesn't work for problems where you have a root in the denominator that's not by itself. So an example of that might be something like 12 over 2 plus the square root of 5. So that problem's a little bit different for a couple reasons. One question you might ask about this problem is, can I do regular 12 divided by regular 2? Normally you can do like regular number on the top divided by regular number on the bottom. The issue here is that I'm not allowed to do regular 12 divided by regular 2 because the 2 is part of an addition problem. And we know we are never allowed to cancel out parts of an addition problem. So I can't do any canceling at the start. Additionally, if I tried to just multiply by root 5 over root 5, I'd get 12 root 5 on the top, and then I'd have to distribute on the bottom. I'd have like 2 root 5 plus 5. I'd still have a really messy problem. So the issue is, if you have an addition or subtraction problem in the bottom, if your root is not by itself, instead of multiplying by the denominator by itself, we have a neat trick, which is that we multiply by the conjugate of the denominator. Okay, so you guys might remember from a homework a few days ago, a conjugate is if you take a problem with a root in it and you write it exactly the same way, but you switch the plus or the minus in the middle. So when I say I'm going to multiply by the conjugate of the denominator, I'm going to multiply by 2 minus root 5. Now I obviously can't do that just to the bottom. I have to do it to the top and the bottom. Why? Well, because whenever you multiply something that's the same on the top and the bottom, you're just multiplying by 1. So you're not actually changing anything. So you're just giving it a different way to look. And the good thing about multiplying by the conjugate of the denominator is that we guaranteed on an earlier homework that whenever you multiply something weird by its conjugate, you always get a really nice integer answer. You always get like a really nice answer at the end. So even though this problem looks really weird right now, it's actually going to simplify really nicely. Okay, so what's going to happen here? We've got to be really, really careful. On the top, I have 12 times 2 minus root 5. That's actually a distributive property problem, because I want to distribute 12 times the 2 and 12 times minus root 5. So I'm going to say 12 times 2 is 24, and then that's going to be minus 12 root 5. On the bottom, I have 2 plus root 5 times 2 minus root 5. So because this is 2 things being added times 2 things being subtracted, that's actually a foiling problem. So I'm going to get 4 minus 2 root 5 plus 2 root 5. And then this is going to make minus the square root of 25, which is minus regular 5. So if you look at everything that happens here, I have regular 4 minus 5. That makes negative 1. And then negative 2 root 5 plus 2 root 5 just cancels out. So all that crazy math led me to a place where I have 24 minus 12 root 5 divided by negative 1. That's a problem I can actually do. What I'm going to do is I'm going to say I'm going to divide everything by negative 1. 24 divided by negative 1 is negative 24. Negative 12 root 5 divided by negative 1 is plus 24 times the square root of 5. So that answer is still a little gross, but it's no longer a weird division problem. I rationalized the denominator into a nice number, and then I was able to actually divide everything by negative 1. Okay, so let's do a little bit more work with this. I'm going to keep 2 sides to our board, just so we're really conscious of the fact that there's 2 different strategies we might be using here, depending on the type of problem. Okay, so I'm going to say the multiplying by the denominator strategy always works when you just have a root by itself in the denominator. So, for instance, if you had like 30 divided by the square root of 5, that's a great multiply by the denominator problem because the root is by itself in the denominator. Whereas if I had 21 divided by 3 plus the square root of 2. That's a great multiply by the conjugate of the denominator problem because the denominator is an addition problem. The root is not by itself. Okay, so let's do both of these problems. In this one, I'm going to multiply by the denominator over the denominator. Really, I'm just multiplying by 1. I'm just giving myself a better way to look at the problem. So this would make 30 root 5 over root 5 times root 5, which is root 25. I guaranteed that I'm going to rationalize the denominator. The denominator is going to be a nice number. So I'm going to have 30 root 5 divided by root 25 is 5. And then I can actually do regular 30 divided by regular 5 is 6. This problem has an answer of 6 times the square root of 5. All right, in my other problem, the root is not by itself. You are only allowed to multiply by the denominator if the root is all by itself. If the root is not by itself, you multiply by the conjugate of the denominator. So I'm going to multiply by 3 minus root 2 over 3 minus root 2. I'm really just multiplying by 1, so it's totally allowed. Okay, so what is happening here? On the top, I've got to do distributive property. Okay, so 21 times 3 is 63, and then I'm going to have minus 21 times the square root of 2. On the bottom, I have 2 things being added times 2 things being subtracted, a binomial times a binomial, so I have to FOIL. So 3 times 3 makes 9. I'm then going to have minus 3 root 2 plus 3 root 2 minus, be very, very careful in the back, root 2 times root 2 makes root 4. So what I have here is 9 minus regular 2. 9 minus 2 makes 7. And then the minus 3 root 2 plus 3 root 2, because these are conjugates, cancels out. So by multiplying something by its conjugate, I rationalize the denominator. I made the denominator this nice number of 7. Then this has become a problem I can actually do because you are allowed to divide everything on the top by the bottom. 63 divided by 7 is 9. Negative 21 root 2 divided by 7 is minus 3 times the square root of 2. So I was allowed to do the division problem because I had rationalized the denominator. One more problem, and this one's tricky. We have a weird thing over a weird thing. Am I allowed to cancel out like this root 3 with that root 3? No, because they're both in addition and subtraction problems. Okay, so how do we do this problem? Is it a multiply by the denominator problem? No. The reason you don't multiply by the denominator is that there's multiple things in the denominator. You only multiply by the denominator if you have a root by itself. Okay, so this must be a multiply by the conjugate of the denominator problem. So the conjugate of my denominator is going to become 5 plus the square root of 3. Okay, should I multiply by the conjugate at the top? No. You do want to stick with multiplying by the conjugate of the denominator, and that's because I want to multiply by 1. In math, you are always allowed to multiply by 1. What makes this one hard is that both the top and the bottom are now foiling problems. So you might want to actually pause the video and really take your time with this. This is hard. I'm going to have 10 plus 2 root 3 plus 20 root 3. And then here's the tricky bit. 4 root 3 times root 3 makes 4 root 9, which is 4 times regular 3. The back is going to become 12. So if you simplify the whole top of this, you're going to get 22 plus 22 root 3. Okay, on the bottom, when I go to FOIL, I'm going to have 25 plus 5 root 3 minus 5 root 3 minus the square root of 9, which is regular 3. The bottom is just going to become 25 minus 3, or 22. You are allowed to say, I can now divide everything by the bottom. I'm going to get 1 plus 1 times the square root of 3. Wow.